So question 24 is also a very standard question. So in this question, you have let x and y be two-digit integers such that y is obtained by reversing the digits of x. And we're given that x and y satisfy x squared minus y squared equals m squared for some positive integer m. We want to know what is x plus y plus m. So the idea for this is like you have m squared equals x squared minus y squared. We see on the right side we have a difference of squares, right? So we can kind of like factor this. So we can write x squared minus y squared as like x minus y times x plus y, just by like difference of squares, because factoring is like a lot of times it's helpful. So in this case, we're given that y is obtained by reversing the digits of x. So this is a very common condition. And the idea is you want to like, instead of writing x and y, if I can say like, for example, x is equal to like 10 big A plus big B, like 10A plus B, where A and B are digits. So this is a very common strategy. Like, for example, if x equal like, if x is like 37 or something, then I can write like x as 10 times 3 plus 7. So in this case, our A is our 3 and our B is our 7. So like this is a very like powerful strategy, like writing a number as like the sum of powers of 10. So in this case, we're going to write x because we know it's a two-digit number. We can write x as 10a plus b, where a and b are the digits of x. So we can write it like this. So we can write it like this, where a and b are digits. So that tells us that a and b are between 0 and 9. So the reason this is helpful is because we know that y is obtained by like reversing the digits of x. So basically, we know that x is 10a plus b. So that's essentially saying, x is the two-digit number ab. Like it's the two-digit number ab. So that means y, when you reverse the digits, is going to be ba when you reverse the digits. So that tells us if we write it in this form over here, we would get like 10b plus a for y. So this is a very common strategy where like it's a very common condition you'll see in math problems where it's like, oh, you have some variable and then you reverse the digits of that variable. Then, a very good strategy is to write, like in this case, 10a plus b, and then reverse it 10b plus a. If you had like a three-digit number, like if x was like, a three-digit number, you would write x as like 100a plus 10b plus c. So then the reverse of that would be 100c plus 10b plus a. So this is like a very like common, very powerful strategy. So you should definitely like be very good at using this strategy because it appears a lot. So we have x squared minus y squared. We have this expression here, x minus y times x plus y. So we have that x minus y, 10a plus b minus 10b plus a. If you do the subtraction, that would give you 9a minus 9b. And then if you do x plus y, you do the subtraction, or you do the addition, you do x plus y, you would get 11a plus 11b if you add the two numbers together. So we're given that when you multiply them, you get m squared, right? So we do 9a minus 9b times 11a plus 11b. This has to equal m squared. So we notice we can factor out a 9, right? We can factor out a 9 out of here. We can factor out an 11 out of there. So we would get 9 times 11. If we combine those, you get 99 times a minus b times a plus b. And this has to equal m squared. So now we kind of have this condition. And the idea is like, instead of writing as 99, we know that 99 equals 9 times 11, right? So we know 9 is like 3 squared times 11. So we can just like kind of slightly rewrite this as 3 squared times 11 times a minus b times a plus b. And this has to equal m squared. And notice that like, so this right side here is m squared, which tells us that like the left side is a perfect square. So notice that 3 squared, that's already a perfect square, obviously, right? 3 squared is obviously a perfect squared. But we see that we have this extra factor of 11. So in order for the left side to be like a square, we need there to be a factor of 11 squared on the left side, which means that a minus b times a plus b has to be divisible by 11. So, but remember that a and b are digits, right? So from up here, we had that a and b were between 0 and 9, since we said that they were digits of a number. Notice that like a plus b, the the biggest it can be is 18. That's when both A and B are equal to 9, right? That's the maximum possible value of A plus B. Notice that A minus B, the best you can do is going to be 9, right? The largest possible value of A minus B you can ever get is when A equals 9 and B equals 0, like to make them as far apart as possible. Or I should say, like, this should be actually less than or equal to, right? So we see that the only way to have a factor of 11 in A minus B times A plus B is if we have A plus B equal to 11. That's like the only way we can have A minus B times A plus B be like divisible by 11. Because, you know, like we can't have A minus B be 11 because we know it's at most 9. So we have to have A plus B is 11. It can't be it cannot be 22 or 33 or some other multiple of 11 because we know it's at most 18. So it has to be 11. So A plus B has to be 11. And that just tells us that A minus B is a perfect square. In order for the product all to be a perfect square. So now you can kind of use inspection, right? So if A minus B is a perfect square, we notice that like you can just kind of inspect it from here, that if A equals 6 and B equals 5, right? Clearly 6 plus 5 is 11 and 6 minus 5 is 1, which is a perfect square. So that tells us that like this works, like A equals 6, B equals 5 is a solution. So if we were to plug that back in, we have 3 squared times 11 times A minus B times A plus B. So 3 squared times 11 times A minus B times A plus B. That was the expression we had. A minus B is 1. A plus B is 11. So with these numbers here. So if we were to simplify that, you get 3 squared times 11 squared. And you can write that as 33 squared. And we know this is M squared. So that tells us that M is equal to like 33. So the original question wanted us to find the value of x plus y plus m. So x, remember, we said it was 10a plus b. And we know that a is 6, b is 5. So 10a plus b, 10 times 6 plus 5, we get 65 for x. And y is like the reverse digits of x. So y is 56. So to find x plus y plus m, you do 65 plus 56 plus 33. And you would get like 154 as the answer. And that would be like choice E, which is the correct answer. Okay, so this question is definitely like pretty involved. So like the idea was whenever you have questions involving like, you know, a number is obtained by reversing the digits of another number, it's often a good strategy. Like in this case, we can, if we know that there are 2 digits. So if it's 2 digits, we can say like x equals 10a plus b. So then if we reverse the digits of that, then y is 10b plus a, where a and b are digits. This is a very common strategy. So like whenever you see a question that talks about reversing digits, like 99% of the time, it's always this strategy. Like it's a very like useful strategy, like writing it in terms of like 10a plus b, or like if it's 3 digits, then like 100a plus 10b plus c, or if it's like a 4-digit number, 1000a plus 100b plus 10c plus d. Like a lot of the times that is like the golden strategy, like a very important strategy. So like we factored it as difference of squares, so we simplified and we got 9a minus 9b times 11a plus 11b equals m squared. So you got 99 times a minus b times a plus b is m squared. And then we did some like bounding, some like logic. We found that, you know, we have to have a minus b times a plus b be divisible by 11. So we found that a plus b has to be 11 because a minus b can't be 11. And there are no other possible values, no other multiples of 11 that are valid, that like satisfy these bounds. And then if a plus b is 11, then we need a minus b to be a perfect square. So we found from inspection that a equals 6, b equals 5 works, right? Because 6 plus 5 is 11, that works. And 6 minus 5 is 1, which is a perfect square, which also works. So if we plug in a equals 6 and b equals 5, you know, back into like that equation here, we found that it's simplified down to 33 squared. So m is 33. And since a is 6, b is 5, we know x is 65 and y is 56. So, you know, adding the 3 numbers up, you get 154.